2 days ago, I attended the DevOps Finland meetup here in Helsinki, and I was listening to GE Healthcare's keynote on security in embedded systems. Their main product is patient monitors, and they are both developing and manufacturing them here in Finland. Coincidentally, our headquarters used to be in their building. We met with the general manager a few times, and I especially remember one thing he said. He said, "We want to create a startup hub inside the GE building. This way we expose ourselves to fast and agile innovation, and we will learn from the startup thinking in exchange. And in exchange, we will offer our reach and connections." It's not a surprise he was searching for velocity and agility. An average release cycle of a medical device is usually between 5 to 7 years, of which the last 2 easily get spent trying to pass the regulatory requirements. Does that sound familiar? By the way, they did create the Startup Hub, and GE is currently a leader in the transport monitor market, not an ad. But they have worked hard to decrease the organizational legacy and building a new mindset to remain competitive. On the almost exact opposite of the previous example is an app my friend developed the same Tuesday, two days ago. Or actually, he did not develop it at all. He only worked as a midwife, giving instructions to ChatGPT on what he would like to create. The result is an OpenAI-based pull request reviewer that was developed using the same AI. The concept took 1 hour to create, and as a result, the AI kindly commented on its own pull request. You can see it there. It's a really interesting concept, and I will be undoubtedly it will be included in the mainstream tooling pretty soon. Meanwhile, you can try it out from the GitHub marketplace. And as a side note, if you get bored of my Finnish monotonic dialect, the QR codes will provide you with additional reading while I'm talking. When working in a regulated environment, often added with embedded, the DevOps best practices you find from the internet often fall short. Make continuous releases often. Enable rollbacks in case of a failure. Fail fast. Let's take a look at the 4 key DevOps metrics used by DORA. Development frequency, lead time for changes, mean time to recovery, and change failure rates. When you add in security and compliance, the hardware and its limitations, regulatory verification, and the actual delivery to the devices, you're essentially left with one interesting DORA metric, lead time for changes. Coincidentally, that's the same metric for all other different development practices, whether it's agile, lean, safe, DevOps, or something else. We get to read from organizations that have been able to combine agile pace and very regulated environments. With modern automotive, everyone seems to be talking about Tesla, so I'm going to use mostly other examples. Lunar started as a rogue in the banking sector, a 100% digital bank without mainframes or technical legacy or even physical offices. They have done many things right from the very beginning to fight accumulating legacy. And in the automotive industry, Volkswagen released their fully electric vehicle ID.3 4 years ago, using mostly the same disrupting mechanism as Lunar. Starting without legacy. However, starting without legacy is not an option for most of the organizations. This is why in this talk I propose 4 alternative metrics for DevOps in embedded and regulated industries. And I will carefully take you through why. They are lead time for a release candidate, automated test coverage, ratio of modular dependencies, and cost of delay. In the last part of my talk, I will quickly address a few modern practices and AI-assisted coding caveats. Let's start from the basics. Regulated organizations are usually formed around protecting a successful product. Hardware and software teams are separated from each other, the same way as quality assurance, security are separated from the development. This easily leads into the usual problems of waterfall development, waiting for others to finish. And even worse, building complex ticketing systems and processes instead of direct communication. Of course, the world has changed, and as we talk about Agile and DevOps, things are not that black and white anymore. But when you really look into the organization, I'm sure you can see that the separation of responsibilities is still very much there, leading to the crux of Conway's law, designing your products in a non-optimal way, usually based on the processes and not functions, or even better, flow and interactions. The concept of team topologies is now 4 years old, and I hope you have already heard of it, or even better, skimmed the book. I'll briefly revise it for you. The modern R&D organizations are divided into 4 kinds of team compositions. The first one is stream-aligned teams, the teams that deliver value to customers. The second one, complicated subsystem teams, handling a complicated area or a specific component, for example, sensors of a vehicle. Third one, enabling teams, enabling new practices within the organization. So, for example, enabling new security practices or DevOps or similar would be an enabling team. And then fourth, and in this talk, maybe the most interesting part is platform teams. They provide internal services or tooling for other teams as a platform. And the important part of team topologies is not actually the teams themselves, but how they interact. The teams seek to provide their services as an API. And listening to Conway, this should lead to developing services as an API. Software development, as we talked during this conference, is relatively linear in nature. I know many of you would like to challenge me, but that's besides the point here. Even before DevOps was coined, writing browser-based applications and getting them into production was always the easiest part. Cloud-native service development has been a very good example for all of the latest and greatest in DevOps. And since it's a very efficient way of developing and delivering services, it will probably remain as such in the future. In embedded and more regulated areas, it has never quite worked like that. So looking at the software development curve in orange here, and following the previous slide, modern software matures quite linearly. But when we add new hardware development on top of that, you can see that the development will never go quite hand in hand. The different nature of developing embedded dictates that the software and hardware development will be synchronized only for the brief moment the hardware and software are frozen and sent for the review and release process. So, looking at the simplified embedded version of the earlier cloud-native process, you can already see that it's not going to be a walk in the park. Embedded has many natural differences that will inevitably make the release process more complicated. Actually, the process looks more like the following, but let's not dive too deep there. As we have now established the difficulties, let's take a look on how organizations have addressed these issues. And to all of you working in embedded, I completely understand that often the biggest issue is already in the integrate part of this illustration, as the software and firmware simply do not integrate or cannot be installed on the device. And it might actually take days or even weeks between installations. So I'll hope you'll find some advice from my talk today. Approaching the development phases from the team topologies point of view, as I mentioned, the architectures have transformed into being API-driven. So for Volkswagen ID.3, they did a fresh start for the fully electric vehicle development. And as a result, they were able to build a new culture of software development and introduce two key elements of modern vehicles: the Automotive operating system, which they call the VW OS, and the car platform Modular Electric Drive Matrix, or MEB. These products are already in use for many brands outside Volkswagen and inside, and the usage is expanding. One of the key features of these innovations is to separate the underlying concerns from the developers. For example, third-party supply chain and compatibility, as the services are consumed through an API or an SDK, a software development kit. Volkswagen's competitors have also created very similar solutions. To give an example, Google has their Android Automotive OS, which is gaining market share, and Mercedes has their MMA, or Mercedes Modular Architecture, which should be released next year. I think you can already start to see a pattern here. Together with GE, we developed the testability of their devices and simulators and made a shift left in the automated testing, leading into earlier detection of regulatory issues. You can see the example on the slide. You should be able to read and understand the imaginary regulatory requirement run as an automated acceptance test, which means that what you read is actually at the same time the regulation and at the same time automated test. So quality assurance and particularly testing is usually the part that takes most of the time when trying to release or deliver a product, and usually both before and after the version freeze. Automated testing is the key for DevOps. And even while it's now less talked about, you simply cannot survive without extensive automation. And this is why I encourage everyone listening, especially if you're not directly involved in test automation, to find out how you are doing test automation in your organization and how the results are being used. Test automation is quite easy in browser-based applications, and that has changed two things in the embedded world. The first one is taking testability into account in the hardware design and the development kits, as previously. That leads to reasonable testability. And the second one is just using browser-based applications within the embedded environments. And Android Automotive OS is actually a very good example of that. Going back to the team topologies, a platform team is a perfect concept for providing a service such as a testing farm. What this means is that the stream-aligned teams or developers are using centralized hardware resources through an API. Again, a pattern. Especially in the hardware design phase, there usually is a scarcity of new prototypes. And either the simulators are modifications of the previous version, or then they don't exist. The immediate benefits are easy to see. Testing farms work in economies of scale and as a more efficient resource usage. Managing the testing laboratories should anyway be a service instead of the shadow IT built into the R&D teams maintaining their own testing equipment. GE actually has a good example. They both develop and manufacture the monitors in Finland, which means that they've made more stream alignment between the software and hardware. So it's a different way of approach. Usually new versions of the software are tested at least partially on the old hardware until the new hardware is available. Using farms, everything can be tested immediately as the new hardware is available. The same goes to all of the different configurations that you would need. Okay, time to move to security and compliance. The key point to remember in automation, in automated testing and in security is that the later you find an issue, the more expensive it is to fix. And the more probably you will accumulate technical debt while fixing it. In the QR code, you'll find my lightning talk from November, where I compare software development to fine dining restaurants. Compliance works the same way as in restaurants. If preparing your ingredient takes half a year, you cannot reject it just before the dish is heading to a customer. Or you can reject it, but you cannot expect it to be fixed. And imagine the potential costs. Attaching security and compliance into the development process helps you address the issues early. There are two key aspects regarding that. The first one is using automated security tooling and taking the security team into the process so that you build a common vocabulary and agree on the requirements together. The second one is building the software BOM, or bill of materials, in such a way that you can link all dependencies and make sure nothing has changed between the development phase and the release phase. Apologies that the font is so small, but at least you have something to read as I'm talking. Also, I'm confident some of you might take a screenshot, so just go ahead. Regards for these slides go to GitLab and Stefania Chaplin, who presented automated security testing and tooling at in one of our events in Aarhus last year. On the left side, you will see a quite extensive list of tools that you should use to connect your developers or stream-aligned teams and the security teams. The point is to move as much automation as possible into the development workflow and feeding that information to the security teams. It shifts security left and builds common vocabulary. Most of the developers don't actually understand all of the various security requirements and, to be honest, not everything that the tools output. And some of them don't know how the tools work. So the faster the feedback is given, and the more developer-friendly the feedback is, the better outcome. Your homework is to check out all the different automated security types here, and of course, apply them in your environment. Bill of materials is a common term for embedded development. A list of components, assemblies, versions, and configurations needed to manufacture an end product. SALSA, or supply chain levels for software artifacts, defines a security framework how to do the same for software bill of materials. Your software has to be defined the same way as you define and manufacture your components. As Mark already said, Kelsey Hightower gave a great keynote on SALSA last November. You'll find it through the QR code. If you look at the illustration, there are a total of 8 different places where you might introduce a vulnerability into your software. The key takeaway is at any time. The only way to address this is to implement the correct security protocols and build a development pipeline that verifies everything you create. Through this conference, you will hear speakers explaining different ways of addressing the vulnerabilities, and the amount of automation you can use is tremendous. Both GitLab and GitHub provide automated tooling to address most of these, and there are many tools to create and verify the BOM for each build and release candidates. Okay, let's spend the rest of my time looking at some of the modern practices. I was supposed to use an image of a platform here, and the only reasonable way to convey a platform I came up with is an oil rig. And, well, it wouldn't quite be in the spirit of my topic today. Instead, I will use Runway, which is the internal developer platform created by American Airlines. For the QR code, you'll find Jason Walker giving you a tour of their platform, but they have succeeded in building a platform that extracts the pipeline and operations environments into templates and provides it, you guessed it, as an API. As a developer, I would say they've succeeded removing the difficult and the mostly boring infrastructure work from the developers. But of course, they feel differently. That's why different team topologies. Similarly, as the collaboration with quality assurance and security, a developer platform should be provided by a platform team. That decreases the cognitive load and improves the speed of creating and delivering new innovations. Here's an example of a platform configuration for an application. It's heavily modified from what Lunar Bank is using, but conceptually it follows along the same lines. Once again, as with the test automation example, it should be readable and understandable by any one of you. Lunar has created a tool called Shuttle. See the QR code for more. It consumes an understandable configuration file, something along this example, and produces the pipeline and deployment configurations for the application. As you've surely already heard during this conference, the concept of developer platforms is revolutionary in the abstraction of DevOps services. In my talk, it would be kind of lame not to mention over-the-air updates, which is a big introduction from the automotive industry for the general population. And it's definitely something that Tesla has been a trailblazer in. NASA employed over-the-air in 2020 when the Perseverance rover landed on Mars. They had 9 months more development time by sending the rover and continuing the development during its flights. The new software was then uploaded immediately after the rover landed over the air. Or is it over the vacuum? In the QR code, I've linked a page that lists a quite recent over-the-air update capability status of each vehicle brand. And you'll find that many manufacturers are still unable or reluctant to update their firmware over the air. That will be an interesting competition to follow for the big players in the future. And I think Kalle from Sensible 4 will be addressing this topic later today in his session. Also later today, Adrian is going to talk about outsourcing your continuous deployment pipelines altogether. Using modern services such as Fly.io or Vercel, or Heroku for that matter, outsources the build, deployment, and operating your online assets. The amount of features and performance put behind these services is very, very difficult and expensive to replicate internally. The concept of NoOps helps smaller organizations to outsource the parts that are painful to build internally and often do not add any core business value. And for bigger organizations, this approach helps experimentation and piloting new services with very little effort and organizational investments. Culturally, it reminds the same way as AI-assisted coding, how easily many things that were complicated just a few years ago can be achieved today. Well, my last topic for today, I promise. I still have to address the AI-assisted coding caveats. The whole conference has been talking about AI-assisted coding, and it's my responsibility to talk about the other side of it. This is also the ugliest slide that I have, so congratulations if you made it all the way here. Both Martin Woodward and Peter Murray from GitHub talked about the benefits of Copilot yesterday. And especially Peter addressed some of the issues like security. I will, however, explicitly mention the most important issues just to make sure you are aware of the current status of the potential problems. It doesn't take anything away from AI per se. As Martin said, AI-assisted coding will very probably evolve the IT industry in the next 5 years more than it has evolved up to this point. So the first one is, AI does not take any responsibility for what it generates. The developer is fully responsible for all aspects of the final work. Of course, different providers of AI coding have different terms for this particular part, but you should still consider it as that. Secondly, there are a number of legislative processes going on to define the copyrights of AI-generated code. But as of today, interestingly, the copyright can only be given to a natural person, which means that it hasn't been defined. This means that currently, in order to create the copyright, the developer has to somehow alter or change the output the AI is providing. And even while there are strong measures against it, there is a possibility where the AI actually generates code that someone else already owns the copyrights to. Peter talked about that yesterday. Copilot has already taken this into account, but it doesn't necessarily concern all tools. And last but not least, AIs have different policies on how the input data is collected and handled. And honestly, you cannot yet know for sure how the AI engine processes your data, which means it's very important to make sure that you don't send it, for example, any personal or confidential or proprietary input. As a recap of my session, I propose you start following these following 4 metrics in your embedded development to better understand and evolve your DevOps capabilities. The first one, lead time for a release candidate. Essentially the engineering lead time, measuring the time it takes your organization to prepare something for a release, even if the release doesn't happen immediately. Second one, automated test coverage. This is quite self-explanatory, but really important. It helps you connect the software and hardware teams and prepare for example, regulations or certifications. Third one, ratio of modular dependencies. Embedded services almost always have modules or components that you simply cannot change for various reasons. The more you have strong dependencies to such modules, the more you collect technical legacy, and the harder your future development becomes. And fourth, the cost of delay. Maybe the most revealing metric in embedded development. Generally, the earlier you find an issue, the cheaper it is to fix. And for embedded, the supply and delivery chains are often very, very long, which means that the cost of delay is potentially very high. By the way, acknowledging and measuring this often helps you get budgets and resources for developing your DevOps capabilities in your organization. Thank you.
Thank you, Marko. Well done.
Beautiful.
Thanks.
Yes. We want to raise a couple of questions and comments from the chat right now.
Yes,
Are you
please
ready
do.
for that?
Yeah, roasting.
Awesome. The first one is from Ferrix. Shifting left is the mantra. However, what should be shifted right in the embedded domain?
Ooh.
Yeah.
So shifting right would mean platform teams, honestly. Like providing services as an API, which was my mantra for this particular speak, means that some of the services don't need to be the concern for the developers or the streamlined teams, but instead they can consume them as services. So the VW OS, for example, for Volkswagen or Android OS, they've done it in such a way that they provide the services as an API. The same way you would use the internal developer platforms, the test automation farms, or even some of the parts of the security tooling as a service. So it's kind of course, it's shifting left because it's happening faster, but in a sense shifting right because you outsource it into a platform team or then outsource it altogether.
Thank you.
Very nicely done. I thought that was a wonderful question. And thanks, Ferrix, for all of the... Ferrix was in the chat pointing out how we're still talking about things 40 years later,
yes.
but look out for the next 5 years. So,
yeah.
But Anton Backkonen had an interesting question, which is like device or why not car farms? I love the car farm slide, by the way. That was
Thank you.
Genius. But device farms are great for dynamic allocation of testing, but the infra management can be a lot. Maybe not an unsustainably lot, but that's not your trivial Internet as Code gig either.
Yeah, that's true.
So this has some consideration forming teams and roles. What would you like to comment about?
So everything he said is true.
Absolutely.
And when we go, so if we look at what's happening in the automotive industry is the similar services as an API type of a thing, which means that the platform, so MEB by Volkswagen, for example, is used by almost all of their brands. And then, so Volvo has their own, Mercedes has their own, and there is going to be competition on which one's going to win. Mm-hmm. And there are a few that will win, of course, but the concept will be the same. So the testing farms don't necessarily either are something you build internally, but use as a service, mm-hmm. or then you find a way to simulate, mm-hmm. or how some of the vehicle manufacturers even do it in 3 stages. So first one is simulation. The second one is having the chip you're developing as a real hardware, and then simulating all of the inputs and outputs. And then the third one is only then the full vehicle configuration, which means that economies of scale will work there as well, which means that some of the parts will be inevitably used as through an API.
And I think you had something in your slides after the question came, which is like cost of delay. Oh, so if you don't have this, then cost of delay, I think, can be a really big thing. You raised something that I hadn't thought about, which I think is really fantastic. Like I mentioned yesterday, for some reason, Free Software, Free Society, Richard Stallman's book is on my bedside table at the moment.
Oh, yes.
And you made me think of this with ChatGPT writing software that's not copyrighted. And oh my gosh, are we on to something here?
Oh, yeah. Yeah, I had a bunch of slides on the open source as well, but I realized I would have hogged the whole conference to start talking about those parts. But Mercedes actually has their FOSS, or free and open source commitments, and it's worth a read. And it approaches the same thing from another point of view. So there's going to be the AI generated, what's the copyright, and then there's going to be the open source side. So if we look at any of the manufacturers today, they use very much open source in everything that they deliver. And some of the products have even been open sourced. Almost actually all of them run on Linux. So there you go.
All right. Okay, really cool. You mentioned Linux. Are there any things happening in the platform space that are interesting here as well that you'd like to comment on?
I'm not such a car freak as I would love to be, but Porsche Macan is currently using the Cariad VW OS currently. It's due out beginning of next year, and it's gone over the budget many times already.
Okay.
And there are some hints from Reuters actually that they are considering different options for the OS in the future. Okay. They might be, they are just it's like nothing is confirmed, but I can see that there is some electricity going on. So when Porsche changed their IT head and he started building their own IT department, you can already see that there is a underlying competition. And maybe next year we get to address that one.
Okay. Really, really cool.
There is a comment in the chat that I would like to read out, as is about what you said about the testing in hardware. It is reassuring how important it is to find ways to speed up even test with hardware in the loop and make it part of the pipeline. And this has a lot of upvotes here as well. So it's sparking a lot of emotions here as well.
Fantastic.
Yeah. Do you want to raise that? Any other key points on the testing with hardware part?
So there is one thing I'll raise immediately. They used hardware in loop, which is a term used in embedded. So you have different stages of testing, and hardware in loop is oftentimes the most difficult, especially when you're just creating the first version of your application. You don't have the protos available. And yes, I wholeheartedly agree on the feeling side, and often the frustration the legacy organization might put onto you when you don't have any access to the people nor the hardware who could answer the questions you have on your SDK problems, for example.
And I'll just mention in that one, it's no excuse not to have something in the loop for your pipelines that is performing some smoke tests at the commit or pull request stage. Oh, well, we don't have the protos yet. It's like one of the things that I love that you mentioned, Marko, was take the old test cases and run them on the new hardware. It's like, hallelujah, why are we not doing that? And it's because many of the companies don't yet have these farms running with hardware in the loop.
Yeah.
The same as with the monitors. Like, we have this new version of monitors. How many % is it regulated? Click of a button. Oh, 75. Let's start working.
Okay, cool. All right, and then I think there's one last kind of thing that came up, which is that the life cycle of these hardware products is much longer than what many software engineers might think about the life cycle of their software being.
Yep.
So are there any implications there for...
In team topologies, you have the stream-aligned teams, and the point is to be end-to-end team. And the legacy organizations, and apologies to everyone who kind of thinks them as being in a legacy organization, you can always fix that. But in legacy organizations, you are quite often insulated into your own concerns, which means that many of the bigger embedded organizations, the people don't actually know when is something going to be released. They're like, okay, we've frozen this. We have this salsa thing done. We're quite okay. Yet you don't see any news of the release in the next year. And it's confusing. So being stream aligned, end-to-end driven should give also some sort of an understanding for the people working in organizations on what's happening before and after my role in this particular product. Okay. That's very important, by the way.
Excellent. Okay.
Yes. There is one new question from Henry. Any thoughts on how to manage supply chain issues in automotive? As it's quite hard to sync with other larger partners as they are still operating in yearly planning mode.
Yes, I know. And this is, when you go to any regulated environment, this is going to be one of the key questions. And there are only two answers I can give. The first one is by time, which is not making anyone happy. But the bigger you are as an organization, and the bigger power you have over these suppliers or third parties, the more probably you can start changing, for example, the contracting into the direction of DevOps or collaboration, or say, let's use GitLab or GitHub. I want you third party to commit into ours so that we can get you into the CI/CD loop. So the time is first one, and the second one is persistence, which is, by the way, the same thing.
Really, really nice. Okay. Thank you so much, Marko. And thank you for sharing all of this for our audience. And it was a fascinating discussion.
Yeah. Thank you so much.
Right. Well done. Thank you.
Good job. Hi, we're from Eficode, the proud organizer of the DevOps conference.
Our goal is to uncover cutting-edge talks, emerging ideas, and DevOps trends, providing a global forum for practitioners and decision-makers to learn and grow.
We would love to also explore how we can help you excel in DevOps together. Visit us at eficode.com and enjoy the inspiring talks at the DevOps conference.